Hello everybody, and welcome back to the channel. This is Michael, KE4EST, and we're back here with the HP Model 410B, the vacuum tube voltmeter. And I'll show you kind of what I've done so far. And first of all, you can kind of see here, maybe get some light on it. I've cleaned up the face and the knobs. And right here was some kind of there was tape here that somebody stuck a piece of tape there, tried to rip it off or scratch it off, and you might can see it if I tilt it around. There's still some scratches and stuff in there. It's smooth. I take some adhesive remover and then 99% isopropyl alcohol, but it's still got some ridges and stuff in it. Or somebody had, when I got it, they tried to peel the tape off, scratch it off, and use something sharp like metal or something, a metal screwdriver to get it off or whatever. I don't know what they use, but yeah, it left a little bit of a mess, but it's not too bad. And then, let's see, here, put you in on this here. This paper capacitor was, I replaced it, put a terminal tie strip in there and replaced that. And this is kind of interesting. If you look at some of there are different revisions of this, different serial numbers. The earlier ones had a 1 microfarad oil filled metal looking capacitor in here, and then this one, has this, which is 4 microfarad. The schematic, every schematic I can find, even if you find the older one or revised one, I'll say 8 microfarads. So that's interesting. But anyway, I replaced it with the 10 microfarad because I had plenty of these. These are really good Panasonic 10 microfarads. This is just some lead dress here, this blue you see that's on there. So replace that. This is still in there for aesthetics and for looks, but it's no longer hooked up. And usually I reach and clip all these out, but it's not near anything, touching anything to cause any problems, so I just left it. But it's no longer in circuit at all. I've heard of people say, well, if the capacitor's out, or if it's going to go out, or just in case, it don't hurt to parallel them. Just stick you one across there, use the same, these tie points, and just put one parallel. That way, if this one goes, you still got this one because it's in parallel. You may have a little bit more capacitance, but as this one goes out and starts getting weak, this one will still, your new one will take in. That's a very, very bad idea, because if these things start getting leaky over time, right? And start turning into resistors, and even it ain't gonna matter if it's like putting a resistor across the new one. It's still gonna cause problems, and if they go shorted, it's still gonna cause a problem no matter if this is in the not. So I always disconnect all that and mount this without that. You either take this out, or a lot of times I'll leave these for aesthetics. But anyway, let's see. I cleaned everything up. All the potentiometers and knobs and contacts in here. Let's put this a little different, back out a little bit. Like all the contacts, and sprayed them with the contact cleaner really good, and work them back and forth. Did all that. And then here you can see, that light where it's not so shining. Kind of hard sometimes with this metal, got a glare, but another terminal tie strip here. Took out the selenium rectifier and put in a couple diodes. And I started putting just the one, but decided, well, I'll just go with 2. If we put 2 in series, that'll bring it closer to what it was. and these are 1N4005s. Most of the time, a lot of times, and if you read what people change out when they change out cylinder rectifiers, they'll put in a 1N4007 or a 5408 or something, which is a fatter version of this, a higher current capabilities. It'll handle more current, the 54 series will. But there's hardly any current in this circuit, so these are fine. And there's no reason I chose the 4005s over the 4007s. I just have plenty of them. I've got tons of the 4001s, 4s, 5s, 7s, tons of them, and I order in bulk, so I've got plenty of them. So that's the first thing that come out when I was looking in the diode cabinet. I come across a whole bunch of these brand new, so I said 4005s will be just fine in this circuit. There's only 8 to 10 volts on this side, and then over here we're looking for a negative 1.2 volts or something close to that. It won't be exactly, because when you adjust that, I'll show you when we go through the alignment, but when we adjust this potentiometer here to match so the ohms will read right, this will change. You can put a meter on it and adjust that, and it won't be exactly 1.2 volts. I already plugged it in, brought it up slowly on the variac. Everything was fine there, so I plugged it in and did a voltage check here, and it's pretty close to what it should be. So what I did find out was if I used one diode and adjusting this here to get it close to negative 1.2 volts, or close to it reads on the face like it's supposed to, then I had to have this potentiometer all the way one way to one, stop, almost the stop. So you don't want to have something like that as things change over time and age and whatever. These ain't so bad as selenium rectifiers, but other things in the circuit, resistors get hot over time. It's in the circuit and kind of drift a little bit. If you have to come back and do just a quick realignment and not have to change any parts, you may find out where you have to, I ain't got no more to turn, it won't go no more. So by putting two diodes in, it brought it more so that the center is where it's at, so that's always a good thing. So that's about it. I've checked pulled the tubes out and checked them. They check good. That's really nice, especially since two of them are HP. Changed out the capacitor, took out that selenium rectifier, cleaned the face up. So what I'll do now is put it in the cabinet and plug it up, turn it on, get it warmed up, for a while. Before you do an alignment on anything like this, you need to make sure you have it in its environment, so it's in its case. There's some things you can't do like that. It's not designed, where it really wouldn't matter. And then sometimes just poor design by the factory or the company that designed it, where you're like, man, this really should have been designed where I could have got a diddle stick or something through a hole and decided to adjust it. But this one's got everything on the back as you've seen before, except for the 30 volt, 100 volt, and 300 volt AC. And I'll just do that off camera. But all the rest of them's in the back, so it needs to be put in its case, turned on, let it come up to operating temperature. The book says 15 minutes. I like to go longer than that. At least a good 30 minutes to an hour. Let it get good and warmed up, and then go through the alignment procedure. And we'll see how accurate this thing is and how good it works. So when I get that done, I'll be back. Okay. I've had this thing warming up for a while. Now, one thing I do want to mention, you want to do before you plug it in with an unit unplugged, this is any type of instrument like this, is this zero set here on the face of the meter itself. Adjust that counterweight that's in there. This here you want to adjust. You might not want to use a soft plastic like this, but you want to adjust this with it unplugged. Make sure it's dead on zero. And then plug it in, let it warm up, and get ready for the calibration. Okay. And when you're doing your calibration, you're like, well, what do I use? If you've got the means, facility that's got the really high dollar calibration stuff, that's great, use it. But, well, let me say this, you can set up, stuff at home, for the hobbyist, that's going to be close enough for something like this. If you need something that's got 8 digits of accuracy or whatever, there's instruments for that, and there's a lot of thousands of dollars that goes with it too. But for the hobbyist, you want to do this, if you got a pretty decent, multimeter, you can set you up a voltage divider circuit or a power supply, tune it down to the voltage you need, check it against your digital multimeter, make sure it's right, and then, then go from there to this. It's probably going to be fine. And then one thing I want to mention too is, I was going to say, if you've got that, now some people do it, your job or something, may have access to some fancier test equipment and things like that. If you take this to your job and say, well, I work at such and such place and we've got some stuff to, calibrate things. One thing you got to remember, you may take it there and they may have power line conditioners and, UPS systems and everything. It might be set to run exactly at 120 volts, which is most common nowadays. And then you bring it back home and you plug it in the wall and you're getting 123 volts or 117 volts or whatever, and that's going to affect the accuracy of your calibration. If you take something like this and send it off to somebody to calibrate, these calibration places, something like this that's got a linear supply in it, with a big heavy transformer, they're going to ask you what is your average line voltage at your, some people's got the money at home to, their home shop to say, hey, at my house, or most of the time it's a business though. You got a business and you're sending your test equipment off because, it costs a couple $1,000s to have it calibrated. And they're going to ask you what is your average line voltage. And they're going to set their variacs and, isolation transformer variac setups to what you tell them, and that's what they're going to calibrate it at. Because I've mentioned it before in other videos, I've had people say stuff. Well, you didn't say that it should be calibrated such and such. The manual says this, like this one. The manual says plug it into 115 volts. Unless you're in another country and you set the thing in the, open it up and move the jumper for 230 volts. Say if you're in Europe or something. And they'll say, well, you didn't set it to 115 volts, or you didn't. If you did, you didn't mention it. Did you use 115 volts? Because if you didn't, it's all wrong. And I just want to bang my head. I'm like, okay, if I set my variac to 115 volts exactly and do the alignment, I'm not going to have all my test equipment always on variacs. I'm not going to have my radio receivers on variacs. I heard the same thing about, old receivers. It says here, put it, 117 volts or 110 volts, 115 volts, and you've got to go by that. And if that's fine, what they're mainly saying is don't plug it into a 220 volt outlet. Back then people ever called it 220. Here in North America anyway. Now it averages 200 and some volts. Here it's about 245. If I plug a meter into it, it's about 245 volts. My line voltage here is about 123 volts. It's been that way for a long time. It's not 115. That's mainly what they're saying is don't plug it into 230 30 or 240 volt line, you know, this unit needs to be plugged in 115 volts. Now, one thing about the manual on this one, it says plug it into 115 volts. I'm paraphrasing, or make sure it's plugged into, you know, appropriate if it's a little bit above or a little bit below, you know, in the environment that it's going to be in. So this is going to be used here. I'm running about 123 volts. So, you know, we brought it up before. When I brought it up before, I don't think I showed that on camera, but when I brought it up, tested it, yeah, I used, you know, had the current limiting, you know, isolation transformer and variac set up. But now I've got it plugged straight into the wall. So I can get the full, you know, regular what the voltage is going to be here, typical. Because I don't want to set it for 115 volts, at, you know, set, you know, at 115 volts. And, you know, yeah, I know it's not going to be off a whole lot. It ain't like, you know, if I'm measuring 0.6 of a volt here and it's going to be way over here. But, you know, it's going to be off. So, and to me, you know, I thought, well, it don't really matter that much because this is, you know, old analog thing. It ain't going to matter. But when you need to always keep it in your mind, you know, don't listen to people that tells you stuff like that. When you're going to do something like this, do it right. Take your time to do it right. And if the calibration's off on this, and you use this piece of equipment to calibrate something else or to test something else that you're hooking it into a circuit that says just potentiometer R28 for 0.7 volts, and you do it and you put it on 0.7 volts here, when really, if you put another meter on it, that's 0.8 volts or something. And some, you know, things in receivers are real picky like that. They need to be really close to what they say, not, you know, even a few tenths of a volt off will make a difference. So I'll get off my soapbox on that, but I just wanted to kind of mention that. I've just run into people and they're like, well, you didn't do it right. Well, I'm not going to leave it on variac all the time. So, and mostly with receivers, you know, the old receivers, you know, the tube receivers, it says in the manual the calibration procedure is this, and you didn't do it right. Well, when I unplug it from that and plug it in the wall, it's going to throw the calibration off a little bit because the voltage is going to go up. Like right, if I plugged it in 115, set my variac for 115 volts, and then unplug it from that and plug it in the wall, and I put it where it's going to go, the voltage is going to jump up, you know, about 8 volts. So your high voltage is going to, you know, jump up maybe 16, 20 volts or more. So, you know, plug it in to what environment it's going to be in. If you take it to your job, put it on your variac and set it to whatever your house is. If your house is 123, when you go, if you got a nice place to take it and do all the calibration, some nice test stuff, set it to 123. Make sure it's variac used so that when you bring it home, it matches the same thing. So anyway, alright, so let's get to it here. Like I said, I ain't going to do every little thing about it, but I'll just kind of go over it. The first thing you want to do, you know, of course, after you just this, plug it in, warm it up good, let it warm up a good, the manual says 15 minutes, you know, 15, 30 minutes. Longer is better, especially if you change out, have to change out a bunch of tubes, or you just choose to change out all the tubes to, you know, new old stock tubes or whatever, or, you know, some of you can still, like 12AU7s, there's places that make them. You want to go out, you know, all new, change out a bunch of stuff. You're going to have to let it warm up, do a calibration about a month or so. You're going to have to do it again, another month or so, probably do it again. Then you start spreading that out as everything ages, you know, from the heat inside and the expansion and changes. Something like this, it's been around for a while. All I changed out was those two components. You know, it's probably going to be pretty close, but I'll still have to check it, you know, if I'm going to sit here and use it. In a couple months, I'll check it and see how the calibration went, you know, hook up something to it, exactly 1 volt DC, and try it. And that's the first thing I want you to do, is put the selector switch in the plus side. Put this on 1 volt. and you want to take your 0 set, and what I like to do is, what I'm doing is taking the DC probe, I'm holding it, and ground it out to the ground clip. Make sure it's right on 0. Let me bring the camera in a little bit. Make sure it's right on 0. Okay. It's going to settle. And sometimes you can get away with it, and sometimes you can't. But make sure that's on 0. And then you want to apply exactly 1 volt, and it should come over here and match up this 1 volt right here. And you can see we're off a little bit. So if I'm going to go back here to the DC adjustment in the back, and we're going to adjust that. And it's a little touchy. There we go. Put it right on 1 volt. And then you can go ahead and check your 3 volt scale if you want to. Yeah, that's right on it. Now, it may look a little bit off on the camera, the angle of the camera. I'm trying to get it right on, but it may look a little off. But that's pretty close. Right on 1 volt. So, anyway, and that's the thing they want you to do first. AC is the same way, using AC voltage of 1 volt. Go down to the 1 volt. You know, put this on AC down here. Now this is where you want to adjust this to get your 0. And then you apply 1 volt to it, and that's where you'll use this probe here. It's quite warm. That tube in there, you can feel the heat from that thing. It's pretty warm. And you want to adjust the adjustment in the back to get the 1 volt. And there's adjustment in the back for 3 volt, 10 volt, and like I said, 30 and 100 and 300s inside. And then the ohms, like I said, I don't want to go through every little step and bore everybody, because I mean it's pretty much the same procedures. On the ohm side, when you're doing the ohms, what it says to do is put it in the RX times 10, and we're over on ohms. And you go for your infinity set here. Put that right on. Okay. And then go down to RX times 1. And if that don't match, then you got to adjust in the back. Now remember, that's where I changed out, took the selenium rectifier out. Put those diodes in, so that's going to affect things. Okay. I got it on there. It's a little aggravating to get these back through them holes back there and get things right on there. Especially I'm trying to film everything. Bring it in just a little bit. So we're on 3X. On RX times 10, we're on infinity. And that's not matching. So what we want to do is adjust that potentiometer in the back. So if I do that, and that's going to jump a little bit between ranges, it should come back. Yeah, bumped it a little bit. Yeah, they're matching now. So that takes care of that. I just wanted to show you that. Now the rest of them, if something's off, then you take a 10K resistor and put across it, and it's not right, then you're gonna have to change them resistors. Check your resistors though, them precision resistors. But that's it. I mean, pretty much. I mean, there's also the probe. If something ain't reading right, you can't get it right or whatever, you can start checking the voltage going to it. There's an adjustment in the back for that. Things like that. But other than that, the nice thing about this meter is, I know, is if you leave it in ohms and forget about it, and you get busy doing something, I'd bad to do that on the other ones. You're not draining them batteries, because there's no batteries in this thing. But anyway, there's the alignment procedure, and I hope this helps somebody out. Hope somebody got help out of this. If you have any questions, feel free to put them down in the comments below. I'll be happy to answer them when I get to it. Sometimes I get to it pretty quick. Sometimes it might take me a few hours, because usually they'll pop up on my phone. But this here's so far showing pretty good here. So with that, we'll end this video here, and I hope everybody enjoyed it and hope it helped somebody out. And if you liked it, hit that like button. If you're not subscribed to the channel, reach down and hit subscribe. There'll be plenty more stuff like this. And until the next one, this is Michael, KE4EST 73.